What's up everyone, welcome back. Patrick here, moving on to another word problem dealing with quadratic relations. So a bridge's height above the ground can be modeled by this quadratic here, h equals negative 0.5 x squared plus 72, where x is the horizontal distance from the center of the bridge, and we have to figure out how tall and wide is the bridge going to be. Now, before getting into the specifics of this particular question, I want to go over just generally a couple of different scenarios that you're going to run into when you're dealing with bridges, these kinds of word problems, and different formats that this quadratic can take. Now, in this case, notice that this quadratic, a quadratic in general, we have y equals ax squared plus bx plus c, right? Well, notice that in this case, the bx is missing, right? The b has a value of 0. So this quadratic here, it's in the format y equals ax squared plus c, right? In this case, the a is the negative 0.5, and then the c value is the 72. That middle term, bx, is not there. And just in general, whenever you have a quadratic in this format here, the vertex, so whether you're dealing with a word problem or you're just given a quadratic randomly like this, an abstract quadratic, the vertex of this kind of quadratic in this format, it's always going to be at the point 0 and c. Okay, this c value actually represents the y value of the vertex. So the vertex is always going to be on that y-axis. So just in general, here, this particular case, notice that the c value is 72. So the vertex is going to be at 0 and 72. And then notice that we have a negative a value. So that means the quadratic is going to be pointing downwards. So it's going to look like this. Right, so that's how this bridge is going to be modeled here. It's kind of just an upside down quadratic. And I'm going to show you another scenario that you can run into too. It's actually going to be the next scenario. We'll do it in the next video. But in this case, this is the scenario that we're going to be working with, right? So if we plug in 0 for this x value, notice negative 0.5 times 0 to the power 2, that's just going to be 0 times this is 0 plus 72. It's going to give us that y value of 72. Now, here in this particular case, x is the horizontal distance from the center of the bridge. So notice that the center of the bridge is right here. This is maybe not symmetrical of a drawing. This should be symmetrical over here if you draw it on graph paper. So this here is the center of the bridge, right? And so when they say x is the horizontal distance, let's say we have an x value of 5. So let's say that's like right there. This 5 represents the horizontal distance from the center of the bridge. So the center is over here, right? And then this is the horizontal distance from that center, this 5 over here. And then at this x value of 5, we're going to have some kind of height right there. So that's going to be the height at a horizontal distance of 5 from the center of the bridge. And then as that horizontal distance gets extended, right, the height becomes less and less. Notice that it's going downwards, right? And then it's going to get to a point where we're going to have a value here where that height is going to be 0. Now, another thing I want to mention, just with these kinds of quadratics in this format, is that notice that because the vertex is on the y-axis, notice that that's the axis of symmetry. So it's actually going to be symmetrical. And that makes sense because if you think about it, if we take this, we're actually going to have to make a table of values anyway. So let's just start it now. So if you think about it, well, first we have 0, and we know that the h value at 0 is going to be 72. And then you could pick certain x values to go up by. You could go up by 1s. Sometimes, usually when you go up by 1s, you're going to need a lot of x values to get to this endpoint over here because it's going to decrease the height by a small amount. So let's actually go up by 3s in this case. Notice that if we take 3 and we plug it in here, notice that that's going to give us the same h value as if we plug in -3, right? Because what's happening is we have negative 0.5, 3 to the power of 2 plus 72, like that. Well, notice that whether this is positive 3 or negative 3, this bracket to the power 2 is just going to give us 9 both times, right? Negative 3 to the power 2 is positive 9. 3 to the power of 2 is also positive 9. And so negative 3 and positive 3 are going to give us that same h value, and that's why it's symmetrical, right? So at positive 3 and then at negative 3, that h value is going to be the same because it's symmetrical about that y-axis, right? And you could see with the calculation here that because this is the only x value we're plugging in, right, that bx expression is not there, we could plug in a positive or a negative value and we're going to get that same, in general, if we're looking at an abstract quadratic, that same y value, right? So hopefully that makes sense. And so whether we plug in positive 3 or negative 3, that's going to be 9 times negative 0.5. That's going to give us negative 4.5 plus 72. And then this over here is going to give us 67.5, like that, right? So at negative 3 and positive 3, we're going to have 67.5, like that. Now let's go to the next one. So let's try negative 6 and positive 6. So if we plug that in, notice that we would have negative 6 to the power 2, or 6 to the power 2 is 36, so that would be 36. We have to do the exponent first. Negative 0.5 times 36 would give us what? Negative 18. It's going to be plus 72, like that. And then this here would give us positive 54, like that. So at negative 6, positive 6, we're going to have positive 54. You can just keep going down like that. So we're going up by 3s. So we got negative 9, positive 9. Right? If we plug that in, we'll have negative 9 or positive 9 to the power 2 is 81. So we'll have negative 0.5 times 81 plus 72. So that's going to give us what? Negative 40.5 plus 72. And then that's going to give us what? 32.5? No, 31.5, sorry. Like that. So at negative 9, positive 9, right, at a horizontal distance of 9, we're going to have a height of 31.5. And then you can do negative 12, positive 12. And then notice that 12 to the power 2, that gives us 144, times negative 0.5 is going to get us negative 72 plus 72. That's going to give us a height of 0. So that's what we're aiming for over here. So we know that we could plot all these points. So for example, 3, negative 3, we'd have 67.5, 67.5. Then we'd have negative 6, or a negative 6, positive 6. That would give us 54. We could plot those points. And then notice that at 12 and negative 12, we're going to get 0 and 0. And now with this table, or this drawing over here, we have enough information to answer both questions, how tall and how wide the bridge is. And it's basically, how tall is it? Well, that's always actually, if the bridge is given in this format, it's always going to be the y value of the vertex. So in this case, it is 72. I don't know if are we given meters? Yeah, let's just pretend it's meters. Forgot to write that, right? So it's 72 meters tall, right? That's going to be the y value of the vertex. And then how wide is it? Well, notice that it's 12 plus 12, right? So two 12s over here, which would give us 24 meters, right? So you got to get these two intercepts over here, and then the distance between the two intercepts is going to be how wide the bridge is. Right, so that's one scenario that you can run into. In the next video, what we're going to go over is another scenario, just to give you maybe a quick preview of what's going to happen, is that Well, we won't have a c value, so we'll just have ax squared plus bx like this. And so what's going to happen is that bridge in that case is going to look something like this, right? Where instead of the y-axis or a x value of 0 being the center of the bridge, it's actually going to be one end of the bridge. And then the x variable, it's not going to be the horizontal distance from the center, it's going to be the horizontal distance from the end of the bridge, and then that's going to give us certain heights. And then the vertex is actually going to be the middle of the two intercepts. The vertex is always the middle of the two intercepts in this case as well. It's just, in this case, the vertex is going to be at some kind of positive x value, while here the vertex was at an x value of 0. Okay, so notice the difference in the formats. This is ax squared plus c, this is ax squared plus bx. All right, so in the next video, we're going to go over that scenario.